Hello, welcome. My name is Mohammed Rushan Abbas. Today I'm going to be demonstrating Banker's algorithm. I've created this using Bash script on Ubuntu Linux. So let's head into the program. Uh, so here, after the welcome message and all of that, I've declared process and resource type variables with default value 00, right? It's gonna be taking this into this while loop, and we're gonna ask for user for process to plot the process and resource type value, right? If the user enters invalid values, it will print this message, right? If it's less than 0 or equal to 0, and the while loop will run again to ask the values again. Here I've declared 2D arrays for all of the important attributes for Banker's algorithm, like allocate, max, need, available. Available is not a 2D array though, the rest are. So let's move to this part. This is where I'm asking the user for allocation resource type value and max value for that resource type, and this is done using for loop and another for loop that is inside that. Okay, after this we are asking the user for initial available resource for that type. If the user has answered 3 resources type, then they will ask for 3, the program will ask for 3 available initial available resource. So after that we are going to be printing the values user has provided for allocation array, right, and 2D max array. After that I'm calculating and printing the values for need array using this formula, which is max value minus allocation value, and that is then plotted in need array, and it's going to be printed at the same time. After that I'm printing initial available resources that user has provided, obviously, and then I've made two functions here, calculate available and is available. Calculate available will calculate new available resources using this formula, previous available plus allocation value, right? uh, and is available is basically a condition based formula, which will tell the program whether the process should continue or not. If it's in the safe state, it must mean that available is greater than need, and if available is less than need, then the condition met is false, right? And these formulas are called here, the functions are called here in the while loop. Over here I'm creating a queue. Queue is basically how many processes there are, process queue, right? If the process queue is has processes inside, the while loop should run loop again and again. If it's empty, then it should stop. So here I'm checking whether the current process should continue. Suppose first right the first process is 0, then should it continue, does it have enough available resources to satisfy the need. If it fails, then the process it prints out this message that it did not enter safe state, and that process will be removed from the array, from the queue process, right? And it's gonna be entered at the back of the queue. Next, here is an else condition, whether the process entered should enter safe state, right? Then it will calculate the new available, right, for that process, and it's gonna remove that process from the queue. And after all of this is done and all of this processes run through the queue and get removed, all of them, then it will say all processes entered safe state. Thanks for using Banker's algorithm. Now let's run the program, right? Okay, so let's run the program for Banker's algorithm. It will ask how many tasks do you have. I'll say 5, right? Resources I have 3. So now it's gonna ask me for allocation resource value for process 0. I'll say 0, right? for max value for this resource type is 7 1. So I have the question with me, so that's what I'm plotting values from. Let me just do that. Now it's process 1, it's asking for process 1. I'll say 2 3 0 2 0 2. Now process 2 3 9 0 0 2 2. Okay, process 4. Okay, now it's asking me for initial available resources that I have to input. So first 0, type 0, then type 1, then type 1, type 2. Okay, so here this is what I've did, right? Then it populated 2D array for allocation. All of those values are correct. Then max array. Then it calculated the need array and and printed all of those values, right? This is correct. And then it printed initial available resources that I provided. Next, current process queue is 0 1 2 3 4. It's processing first process 0. It did not enter save state, so it's on the back of the queue now. Processing 1 entered save state, 1 has been removed. Then new available resource is this. Processing 2 did not enter save state, 2 is at the back of the queue. Processing 3 and 4, and then 0 again. So 0 is now satisfying the available, so this is what it does. And then 2, and this is the final available resources, right? So that's the end of the program, since all of those processes entered save state. Thanks for watching. This was the banker's algorithm demonstration.